Okay, so this is going to be a real quick review of the stuff we've been doing all week. So we talked about points of discontinuity, and we were basically focused on where we have asymptotes, where the graph doesn't cross, okay? And then we also talked about places where it jumps, where we have a point discontinuity, so I'm going to talk about those. We did jump discontinuity when we were talking about piecewise functions, so we're going to go back to that later in the year, but we're not going to focus on that this week. All right, so we graphed these functions. This is the parent function of a rational function. If you're not sure exactly where the graph goes, plot some points. So I plotted some points just to see what quadrant am I going to have my graph in. And I know it's going to be undefined when it's 0, so I have asymptotes there. So I know now kind of where the graph is going to go. It really is that easy. As long as you know what the parent function looks like and you plot a few points, you can find it. We're not going to play around with those. You guys know what to do with that. Write the equation of the function represented by the graph. So we're going to talk about the asymptotes. Okay, maybe we'll have to come back to that. Let me go show you how to find a vertical asymptote. Okay, so when you want to find a vertical asymptote, let me get to the definition. There you go. Any point or line that will make a function undefined. So you're basically looking at your denominator when you're looking at a vertical asymptote. So x plus 5 would equal 0 when x is equal to negative 5. Well, that's your vertical asymptote. Okay, so you've got one right there. There you go, and that helps you to start drawing it. And then anytime your graph has an exponent, your function has an exponent higher degree in the denominator than in the numerator, you will have a horizontal asymptote. All right, and that one's going to, in this case, is going to be 0. And again, all you have to do is plot some points and you can look at it. And again, you also have your graphing calculator to help you. On your test, you're going to need to draw your asymptotes, though. All right, let's go on and look at horizontal asymptotes. Here you go. Here's two different kinds of ways you can have a horizontal asymptote. When the degrees are the same, okay, degrees are the same of the numerator and denominator. They're like this, okay? You're going to have a horizontal asymptote. So let me just show you how to do that because the definition's on the next page. All you're going to do is divide these two guys by each other. Okay, and your horizontal asymptote is going to be y equals 3. Now, in the case where you have the degree is greater than the numerator, the degree in the denominator is greater than the numerator, like this is x to the 4th and this is x to the 0 power, all right, you're going to have whatever's happening over here, okay, and if it's a plus, if it's not doing anything, all right, if it's not having anything added on, like in this case, your horizontal asymptote is at 0, okay? But if you had something added on, then your horizontal asymptote would be y equals 2, okay? Just in case you are a little unclear. And again, you can graph it, you can plot points, and you can kind of get a visual representation of that. All right, I think I paused it. No, I didn't. All right, let's go on and talk about the rule for that. Okay, so the rule for this, again, I just said it, but if the numerator and denominator have the same degree, the horizontal asymptote is the quotient of the coefficients of the highest degree. So those are the highest degree, so those would be your horizontal asymptote. And again, look, it goes through at 3, and then here you've got a vertical asymptote at 2, and you can draw that. All right, let's go and figure out the points of discontinuity of this function. So go ahead and factor. Okay, once I've factored it, I've got x, here's my factors. So I'm going to go and first label what you would call a hole. Okay, a hole in the graph is going to happen wherever these factors cancel out, meaning it's going to still be undefined here, but because they canceled out, it doesn't make an asymptote. So you've got a hole at 3. All right, you've also got a vertical asymptote. Remember, that's the denominator, so that's at x equals negative 2. And then you've got a horizontal asymptote at, let's look at that. X squared divided by x squared is going to be y equals 1. All right, let's go look at, I want to go on and talk about intercepts, because intercepts are important when you want to go and graph. So when you have an intercept, let's, to do an intercept, I didn't write this down as a rule, but set x equal to 0, and then you're going to find your y-intercept, okay? So when x is 0, this isn't there, that's not there, that's not there. So your y-intercept is going to be 9 over negative 6. You can put that in lowest terms, and that's 3 over negative 2, or negative 3 over 2. So when you go to graph it, that's going to help you figure out where to put some of your points. Okay, I'm going to put that right there. Okay, that pretty much explains most of it. You could go ahead and graph it if you needed to by plotting points. All right, here again is your definition of things that go with this graph. So I color-coded it. You can pause and look at that. I'm just going through some of these real quick. Let's talk about dividing. All right, we can do synthetic division, or we can do long division. We want to do long division when we want to find a slant asymptote. So let's go talk about slant asymptotes. Yeah, you can look up long division somewhere. Slant asymptotes, okay? Some of these graphs are going to end up having a slant asymptote. So to find that, you should perform long division. And the reason we do that is because sometimes you are not dividing something that has an exponent of 1. So when it doesn't have an exponent of 1, you can't use synthetic division. You've got to go and do long division. Let's go play around with one of these. Find the slant asymptote for this. So I'm going to set it up. Okay, so I set up my long division problem. I basically put this little guy over here where we're used to doing it. We've done long division before with numbers. Now we're just doing it with polynomials. All right, so now it's very important to keep your place value. All right, so you want your x squareds to all be in a line, you want your x's to all be in a line, and you want your constants to all stay in a straight line. It works like that with long division from when you were in 4th grade. If you notice, when you lined everything up, you had to keep them all straight. Okay, so let's go ahead and now you don't really worry about the -2 here. We're not worrying about that. We're only dealing with the x. So we're doing 2x squared divided by x. What do we get for that? Well, some of the x's cancel out and we're left with 2x. So when the answer is 2x, you got to put this over the x column because you've got to keep them all lined up. All right, now we go and multiply. So really, essentially, you're doing 2x times x minus 2 when you go and multiply these guys together. And so you're doing 2x squared minus 4x. So line those up. 2x squared goes under the x squared. Negative 4x goes under the under the x column. And now we're going to go, and the next step is to subtract. So you subtract the entire polynomial. All right, so sometimes it's a little tricky because you're going to have subtracting a negative, so that's going to be 1x, because negative 3 minus negative 4x is going to give us positive 1x. Let me take those off of there so you don't get it confused with division. All right, the next thing we do is bring down the next thing. So we're going to bring down 1. All right, so now, again, you're taking 1x, this 1x right here, and you're dividing it by that x, okay? Well, that's easy. That's 1. So that's where that answer goes, right there. So then we go and multiply it back. So 1 times x is x. 1 times negative 2 is negative 2. Subtract that, and we get 3. All right, we don't really care about the remainder at this point. We only care about what this line is right here. So our slant asymptote is y equals 2x plus 1. All right, so if you had to graph that, remember, you got to remember how to graph lines. So, you know, at the very minimum, put it in a calculator, but your y-intercept is 1, and it's going to be kind of a steep slope. Okay. All right, let's put it all together. All right, I'm going to choose number 36 from our homework. So I like it because it can be factored and it has a slant asymptote and it will have some holes going on, so we can find some of those. So if we're going to graph this, let's go factor it. All right, so the numerator can be factored as a difference of two squares. And then you've got your denominator here, okay? So we need to go find any holes or any asymptotes so that we can start graphing. So we see that we have a hole right here at x minus 2 and x minus 2. So our hole is going to be at x equals 2. Whatever's going to make that become a hole is going to be that value, okay? I'm going to leave that out there like that for just a minute. Do we have any vertical asymptotes? No, we don't, because we canceled out anything in the denominator, so there are no vertical asymptotes. All right, and then we want to find, let's go find, let's see if there's a horizontal asymptote. I don't think this qualifies for horizontal. So let's go find a slant asymptote. So, there's the answers for something else. All right, so a slant asymptote, yeah, I think this qualifies as a slant asymptote because this degree is higher by one exponent or 1 degree. So let's go find our slant asymptote. So that's going to require some long division, and you have to do this from the original equation. So I've got x squared. We have no x here, okay? There's no x value, so but you have to put something in there for that, and then minus 4. Go through and let's work that out, and we're going to get, I'm going to go fast because I'm running out of time. So I've got x squared divided by x is going to give me an x, and then I go through and I multiply it, and I get this, and then you subtract these, so this is going to become 2x minus 4. So how many times 2x divided by x is just 2, and I don't really care about the rest of it, so I'm not going to do it. So my slant asymptote is going to be y equals x plus 2. So let's go and start graphing this because we want to label something. Let's go find our y-intercepts also. So our slant asymptote is that. Let's go find a y-intercept. So you could look at it and see if you can find it, or you can go and see, well, if I put a 0 in for x here, that's going to go away, and I put a 0 in the denominator, that's going to go away. So my y-intercept is going to be whatever that is. So that looks like it's going to be 2, because negative 4 over negative 2 is 2. So now let's go graph it. Okay, so let's go from the very top. Well, I can't do the whole yet, so we can't do a vertical asymptote because there isn't one. So we're going to move on to our slant asymptote. So our slant asymptote is y equals x plus 2. So that's going to look kind of like, oh Lord, what happened here? All right, that's going to look kind of like this. Okay, there's your y-intercept of that. And then your y-intercept of the graph is also 2, but I'm thinking it's probably not going to touch there because we have an asymptote there. All right, so it might be null and void. We might not have it. Okay, so then we go and we look at it. I think we're also going to have we don't have a vertical asymptote, so that's not going to matter. So let's go and check it by graphing because I'm not sure, or let's go plot some points. I'll give you a minute to do that. Okay, so this was not a good example because it turns into a straight line because look what happens. These two guys cancel out, so the equation just ends up being exactly what the slant asymptote is. Probably not the best example because I want to show you what to do for when you have a real rational function. So I am going to make another example because I'm running out of time on this video. So this would have been this is a great way to study for your test. So make sure you're doing some of these problems. I'm going to write the review down for you real quick. Okay, so here's some of the problems that we've already done for the week. So these will be a really good help for you. I will do one like this on number 43. That's a very important one to do for your test. All right, so enjoy doing this. Study for this test. If you do some of these problems, you're going to do a lot better.